Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is force resolution and applying the vector approach. Now, if you want the theory and concepts on vectors, I have a playlist in statics, complete playlist in statics. And if you want to see or watch the theory behind vectors, then you just look at it, particularly for statics for beginners 1. And you have there the concept, which is the application of this problem here. So resolve the 360 Newton force into X and Y components, U and V components by the vector approach. The U and V axes are perpendicular to each other. So remember that this approach is only applicable when we resolve the force into components along two sets of axes that are perpendicular to each other. If they are not perpendicular, then use parallelogram or triangle law and the law of sines, which I already demonstrated in the previous problems. So we have here the U and V axis. The U makes an angle of 70 degrees with the positive x-axis counterclockwise. Therefore, the V axis, because this is 90, is 70 plus 90, 160 degrees counterclockwise also. Then the force is directed from the point 6, 5 meters to 2, 2. So if we form a right triangle here for the solution as shown, then we can compute this angle that the force makes with the horizontal. And it is directed down to the left. So the x component is definitely this one, which is negative in the negative x direction. The y component is also negative. It is in the negative y direction downward. So for the components of distance, for the horizontal, it is right x, which is 6, minus left x, which is 2. So this is 4 meters. For the vertical distance, upper y, which is 5, minus lower y, 2, so 3 meters. Tangent theta, therefore, is 3 over 4. So theta is 36.87 degrees. So we can compute directly fx without using vectors as negative 360, because it is leftward, negative 360 times cosine of 36.87, or negative 360 times 4 over 5. Remember, we have 3, 4, so the hypotenuse is 5. But in vector form, vector approach, the unit vector of the x-axis is, because this is 0 degree, is lambda of x. Unit vector of x is cosine of 0 degree I, which is I, simply I, plus sine of 0 degrees j. Sine of 0 is 0, so the unit vector x is simply I. And in this figure, this is 36.87. Since we are asked to express the force or resolve the force into x and y components, one way is, I already explained, negative 360 cosine of 36.87. Then in vector approach, the angle that F makes with the positive x-axis counterclockwise is 180 plus 36.87, so 216.87. So Fx therefore is F in vector form dot the unit vector of the x-axis, which is simply I. So Fx is F in vector form 360 cosine 216.87 degrees, where 216 is 180 plus 36.87 degrees I, plus 360 sine of 216.87 degrees j dot I. So remember j dot I is 0, so fx is 360 cosine 216.87, I dot I, which is 1. So it is simply 360 cosine of 216.87, and it is negative 288.0 newtons. As I said earlier, if not instructed as uh, to resolve the force into x and y components by the vector approach, then it is simply negative 360 times cosine of 36.87, or negative 360 times 4 over 5. Hypotenuse here is 5. That's the other way. So that you, you will be exposed to the vector approach also. That's why I applied this. Take note from problem 13. That was purely by vector approach. So Fy, lambda of the unit vector y direction 90 degrees is cosine 90 0i. So 0i plus sine 90, which is 1j. So it is just j. So Fy is f, which is this, dot j. This time I dot j is 0, so therefore Fy is simply 360 sine 216.87 degrees j dot j, which is 1. So it is simply 360 sine of 216.87 degrees, so negative 216.0 newtons. The other way, from this triangle, it is negative 360 sine of 36.87 degrees, or negative 360 times 3 over 5. That's the other way. So that's it. Then for part B, lambda of u is cosine 70 degrees I plus sine 70 degrees j. And the unit vector v, because u and v are perpendicular to each other, is 70 plus 90, so 160 degrees. So the unit vector v is cosine 160 degrees I plus sine 160 degrees j. So Fu is the dot product between f, this is f in vector form, and lambda of u. So Fu is quantity cosine 360 cosine 216.87 degrees I plus 360 sine 216.87 degrees j dot quantity cosine 70 degrees I plus sine 70 degrees j. And by expansion, this is 360 cosine 216.87 times cosine 70 degrees plus 360 sine 216.87 times sine 70. And Fu is equal to negative 301.5 newtons. Fv, on the other hand, so obviously Fu is negative. So the other way is Fu is this component here. Imagine a right triangle from the tip perpendicular to this direction. Since this total angle here is 70, so that means the force makes an angle of 70 degrees minus 36.87 degrees with this opposite direction of the u. Therefore, the direct way of computing Fu is negative 360 newtons cosine of this angle, and this angle is 70 degrees minus 36.87. So Fu in another way is negative 360 cosine of quantity 70 degrees minus 36.87. And Fu is also negative 301.5 newtons. So Fv is f dot lambda of v. So this is f, and that lambda of v, which is quantity cosine 160 degrees I plus sine 160 degrees j. And if we expand this, this is equal to 360 cosine 216.87 degrees times cosine 160 degrees plus 360 sine 216.87 degrees times sine 160 degrees. So FV is 196.8 newtons. Then for the direct way, FV is this component here, so it is positive, obviously. Then imagine a line perpendicular to V from the tip of the force, so this is FV. The angle that the 360 Newton force makes with the V-axis is 36.87 degrees plus 20. This is 20 degrees because this is 20 degrees. Or because the V-axis makes 160 degrees with the positive x-axis, so that means this is 20 degrees. So 20 plus 36.87, that's the angle that the 360 Newton force makes with the V-axis. Therefore, the V component of the force is 360 cosine of 36.87 plus 20. So positive 360 cosine of 20 degrees plus 36.87. So FV is equal to 196.8 newtons. Same as that. Now for your part, I want you to answer this. That's the force for 50 newtons. And it makes an angle of 18 degrees with the y-axis. The u and the v-axis are still perpendicular. The u-axis makes an angle of 32 degrees clockwise from the x-axis. And show that fx is equal to negative 139.1 newtons. Fy is equal to positive 428.0 newtons. Fu is equal to negative 344.7 newtons, and FV is equal to negative 289.3 newtons. So that's it for your part.